Yes, so we have a number of items to look at this afternoon. One item is to finish off the question we started by considering modified internal rate of return and also duration. That is one. Secondly, we also want to check the assignment that we gave you in the morning on estimating the forward rates. So that's what we want to do now. So straight away, let's go into our discussion there. Let's go into our discussion. Okay. So this was the question that I gave you. We asked you to read through this question and wanted you to demonstrate to us how were these rates calculated. My first question is, have you tried and have you figured out how the calculations are done? Did you figure out how these forward rates were calculated?
I started, but I got lost.
You started, but you got lost.
Yeah.
How come? What happened?
It's like the information is too much.
The information is too much. But me, I had told you that don't panic. Just focus on this only. That's all we wanted you to focus on. The bigger question, we are going to do it. But in the last class, we learned how to estimate the forward rates. So I just wanted you to do an exercise, preferably in Excel like this, just to demonstrate that, Mr. Piri, I think we understood. We know how they did it now. Okay, so let's go. Remember, we have the purchasing power parity theory. Okay, so the domestic currency was the Y rand, and the dollar and the euro were the foreign currencies. Okay, and also we had the spot rates given here. Okay, yeah. So now, how do we move? Let's go. Do you remember our formula from the last class? You remember our formula from the last class? How would you find the spot rate? We said that to find the forward rate on the spot rate, find the forward rate, what do we do? How do we do the calculations? Remember your equation? You remember your equation? You remember our equation of how to move? Who remembers the equation? So the forward rate. And in this type, for instance, like in this case, it's on the YR on the USD. So if you want to find that one, we'll take the spot rate in the same format, which is the YR on a single dollar multiplied by 1 plus inflation rate over 1 plus inflation rate. Now, what inflation rate goes here? Which one will go on top? Which one will go down? So that's what you do. Basically, that's your formula there. To find the forward rate, you start from the spot rate. Okay. Now, the inflation rates were varying here. The inflation rates were varying. So now, let us work it out together here. So you say you've got years. Yes. Let's go. 0, 1, 2, 3, and 4. Okay. And then we have your spot rate. You have your spot rate here. Let's start the first one. The spot rate here is given as 101.4. 101.4. What is this 101.4? Let me label it for you. These are, that's the Y range on a single dollar. That's what it is. What's the inflation rate differential? Inflation rate differential, what is it? What's the inflation rate differential? Let's go year one. We look at the inflation rates. Now there's one more inflation rate that we need here. There's one more inflation rate that we need. Which inflation rate do we need? We need the inflation rate, the local inflation rate. The local inflation rate is here. That's the local inflation rate. So let's pick the local inflation rate. Let's pick the local inflation rate. Let's pick the local inflation rate. So to find the differential, we need the local inflation rate too. So let's go. The local inflation rate. Which is here. Okay. So let's go in year one. Remember, I would say what goes on top? What is that goes on top? The inflation rate on the Y rand. So there it's 1 plus 22%, which is 1.22 over down there, 1 plus the dollar. What's the dollar rate? Have you seen the dollar inflation rate for the dollar? How much is it? 1.03. What will be in year two? 1.147 divided by, let's go. What's the inflation rate? For the dollar, 1.03. We go in year three. What is it? 1.098 over 1.03. And the last one there is still 1.098 over 1.03. People, have you checked how we have done the inflation rates? The differentials. Have you seen how I found them? On top, that's where I put the inflation rate on the Y rand. The one where the dollar comes down. The tricky part here is that it was not constant, it was changing. Okay. So in terms of the factors now, you go, you say equals 1.22 divided by 1.03. So that's what you find there. There you say equals 1.147 divided by 1.03. The next one equals 1.098 divided by 1.03. And that one is still the same as this one here. So these are the inflation differentials. So these are the inflation rates. So then the forward rates, you cannot get the forward rates. The forward rates now, you start multiplying. Multiply by what? You take this differential, multiply by that. Then here, we take this one and you multiply by that one, multiply by that. Can we see now how these were estimated? Can you see how they were estimated? My team. Have you seen how the rates were estimated?
Yes.
So in this particular question that we shall do later, these were given. But one of the learning outcomes of this topic is that you must be in a position to do the calculation yourself. So these are the inflation rate differentials. These are the inflation rate differentials. These ones. The challenge for many students that I've always known is what goes on top, what comes down. What goes on top, what comes down. I think that's a challenge that many students have. So let me talk about that challenge. Okay. Let me talk about that challenge. So here's what we do. We look at the quotation here. Look at the quotation. The quotation, they are saying these numbers represent, in fact, you shouldn't pick it from here. We must pick it from the spot rate. we need to pick it from the spot rate. That's the correct place where to pick it up from. So we go, when you look at the spot rate, they are saying 1 rand on a single dollar. On a single dollar. So we are talking about it, so many rands on a single dollar. And when you come here also, your forward rate is so many rands on a single dollar. So this one goes on top, that one comes down. That is the logic. So here, a rand on a dollar. So what happens? The inflation rate on the rand will go on top, 22%. The one on dollar comes down. I hope that has helped you to see what goes up, and what comes down. Using the same logic, let us now deal with it. This one now is Y rand on the euro. So now we're going to put the inflation rate on the euro. So let's go. Now there's no need of reinventing the wheel, isn't it? There's no need of reinventing the wheel. We come here, we do that. And this time around, we are saying on a single euro. This time we're saying on a single euro. I'll put my euro like that. Okay. And in terms of the rate, it's there. It's 142. So come here, you say 142. That is 142. So that's what we put here. That's what we put. Okay. Okay. What of the inflation rate? What we put down here? Let's read. Expected inflation for the next 2 years is 5, then 4. So here, what am I going to put? Next 2 years, 5. That's what you put here again. What do you put? You put a 5. After that, it becomes a 4. Here it becomes a 4. Okay. So let's go now. We divide, so on top we see the Y rand. On top we see Y rand. Okay. Okay, fine, that's okay. I'll change this one. And that's 142. Let's go, let's divide. Let's now do a multiplication here. Multiply by 5. And here we go. We multiply down there, you put the 5. And here, what you put? You put the 4. And if you notice, that's what they had here. You notice, that's what they had here. Have you seen now? Yeah. So let's discuss the challenge that you had faced. Let's discuss the challenge that you had faced. Where was the challenge? Have you picked up where the challenge was? Have you cleared your challenge? Those were the challenge. Have you seen where it was? Look at the arrangement that we have followed. Look at the arrangement. We have arranged our forward rates in terms of the formatting across. When it comes to dividing with our cash flows, it's very easy for us just to divide. So in this particular exam, these figures are given the forward rates. In our last class, we learned how to calculate. I hope this has given you a review of how to estimate the forward rates. Okay. Let's make a move now. Let's make a move. The question that you had last time, did you manage to calculate the payback in that particular question? Did you manage to find the payback? Did you manage to find the internal rate of return? Remember where we ended? Remember where we ended? Where did we end together? Remember where we ended? We ended up here. That's where we ended up. So we are able to estimate the forward rates. We did the cash flows there, the UK cash flows, the US, and we discounted. That we're able to do together. That we're able to do together. The internal rate of return, if you tried it, if you use 29%, 13.4 for the correct answer. Now, let's discuss the concept of modified internal rate of return and project duration. Let's discuss the concept of modified internal rate of return and project duration. Now, you may remember that we covered the concept of duration under the bonds. Remember, we covered the concept of the duration under the bonds. How long it takes for a bond for you to recover the benefits on the bond. And therefore, duration is a form of a payback. So duration is a form of a payback. So this is a form of a payback. Now, what is the story? What really is a story behind this payback? In a basic investment appraisal, you just end up on what? The traditional payback. And what else? Discounted payback. The only improvement we make is to calculate the payback using figures that have been discounted. So we have learned the traditional payback and discounted payback. What is the limitation of a traditional payback? We normally say, well, it's because the figures are not yet discounted. So we're saying the traditional payback, the time value of money is not considered. That is one problem. Time value of money is not captured. What is the other problem? We don't consider all project cash flows. We then consider all project cash flows. We only consider cash flows up to payback. So not all cash flows are considered. Not all cash flows are considered. So we don't consider all the cash flows. Discounted payback does bring some improvement on the time value of money. Discounted payback does capture the problem of time value of money. It corrects that. But what of the problem of not considering all the cash flows? The fact that not all cash flows are considered, what do we do about that? How do we correct that? How do we correct this problem? Because people tell you that, but you haven't considered all the project cash flows. So how do we know that you're making the right decision? Well, the answer is in duration. So duration is a form of a payback which is based on discounted figures, but also which captures all project cash flows. What do? We give a weighting to each of these values. We give a weighting to each one of these figures using the present values. So it's a payback which is calculated by weighting. So it's a weighted average of the time taken to recover the present value of your cash flows. The easiest way of calculating duration is the one that we also covered on bonds, where we take our discounted figures. First, we take our original figures. I'm sure we remember all these figures that we had. What do? What we do is we look at the benefits and we discount them like that. And once we discount them, these figures, we discount them. We get that total there. Then we start multiplying each one of these figures by the year. So we go 1 multiplied by 5032, 2 multiplied by 5871, 3 multiplied by 6044. Then you add up these figures and they give you 34905. So 34905 divided by the total present value of the inflows gives you 2.06. And this 2.06 is a project duration. Some of you may say, well, please, Mr. Piri, do that again. Let's go. To calculate project duration, what do you do first? You take your project cash flows and discount them. And what do you get? You get your present values. And you add up these. Once you add them up, what do you get? 6947. Next, you now try to weight, to find the weights. How do we do that? We multiply each one of these by the year. So this is multiplied by that to give you this. That is multiplied by that to give you this. That is multiplied by that to give you that. You add up, and once you add up, you're going to find 34905. Once you add these, you're going to find 16,947. So project duration is 34,905 divided by 16,947. Now, some of you may say, but you mentioned something to do with the weights, the weighting, that actually you are weighting. How does the weighting come in? Another way of doing this calculation, which probably is not as straightforward, but it demonstrates the weighting, is where you say 5485 over 16,947 multiplied by 1. Please, can you all take your calculators? Can you all take your calculators? Let's go. Take your calculators. I misled you, not this figure, this one here. 5032 over 16,947 multiplied by 1. What do you find? 2 decimal places. What is your answer? What is your answer?
So we have 0.2, actually 0.3.
2 decimal places, 0.3.
Yes.
Okay. Let's repeat the process here. 5871 over 6947 multiplied by 2. What do you find?
We have 0.07.
The last one, we've got 6044 over 6947 multiplied by 3. What do you find? What do you find? 6040.
So we have 1.07.
The third one?
Yes, 0.07. Oh, 1.07, sorry.
1.07. So now you can add. Can you add up the figures for me? So that plus that plus that. What do we find? What do you find? When you add these 3, that plus that, is 2.07 duration. We add these figures.
Mr. Piri, I think the second one is that one is wrong.
Is what?
I think the correct, yeah, I think the correct one is 0.7, not 0.07.
This one is 0.79.
Yes, 0.7.
0.7. Okay, let's go. All right. So are we adding up now? I think you're adding up 2.07. Here we're at 2.06. It's just a small rounding of error. So this is how we calculate project duration. So whichever method you use, the first method is a lot easy. The first method is easy, where you just multiply this by that, this by that, that by that, that by that, and you simply divide. But remember, the definition talks about weights. Say that in the process, we do some weighting. So the weighting is clear here. These are the weights that you are applying to every year. How much of your total present value is coming from that particular year? Okay, fine. Normally we get this not for a lot of marks, no, maybe 2-3 marks, that's all. It's more on the bonds than on investment appraisal or on assets like this. But you need to know that in advanced investment appraisal, we go beyond the payback. Yes, payback. Remember, payback, then discounted payback, and lastly, you've got now duration. So that is the way you must arrange them. So we improve on the discounted payback by going a step further and calculating the duration. Good. What of modified internal rate of return? Modified internal rate of return. What is modified internal rate of return? Let's go back to the basics. What is internal rate of return? What is the internal rate of return? Did you manage to calculate the internal rate of return? I gave you homework that you must calculate the internal rate of return. I hope you did calculate the internal rate of return of our project. I hope you calculated the internal rate of return. I did myself, and my answer was 13.84. Now we say that this internal rate of return, how do we use it? We compare the internal rate of return with the company cost of capital. We do a comparison. We take this figure that we have and we compare it with the company's cost of capital. So like this one, 13.84, the company's cost of capital is what? 10%. So when the internal rate of return is more than the cost of capital, what is the advance? Go ahead with the project. So if a company's internal rate of return is more than the company's cost of capital, we're saying that the yield on this project is better, it's 13.84, compare the cost of capital of 9%. So we say, go ahead with the project. Now, why do we have to go a step further and calculate modified internal rate of return? Why? The answer is, there are some two notable weaknesses. There are two notable weaknesses with the traditional internal rate of return. What are the two weaknesses? What are the two weaknesses? What are the two weaknesses with the traditional internal rate of return? Number one, the traditional internal rate of return is likely to give misleading results or advice where we have non-conventional cash flows. If we have non-conventional cash flows, what do we mean? These are what we call conventional cash flows that we have here. Meaning these are, in these cash flows, we have an outflow at the beginning, followed by a series of inflows. This is what we call traditional conventional cash flows. We have a huge outflow, followed by a series of inflows. But we have some projects where you have an outflow like this, and maybe come year 3, you have a big outflow again, or somewhere at the end of the project. So this sort of cash flows where you start with a big outflow, and somewhere in during the project or at the end, there's another big outflow. We are saying these are not conventional. And the internal rate of return, when it's applied to this type of cash flows, it may give misleading results. Where does that problem come in? Let's go. Likely to give misleading advice where we have non-conventional cash flows, which may give more than one IRR. It may give more than one IRR. Next, it's also based on unrealistic reinvestment assumption. It's based on unrealistic reinvestment assumption. What is that assumption? Based on unrealistic reinvestment assumption, what does that assumption say? That assumption says the project cash flows generated are being reinvested at the project's IRR. What does that mean? That means that these cash flows here, this money here, when we make this money, what do? We reinvest it. But the question that we need to ask is that at what rate do we reinvest? The traditional internal rate of return assumes that this will be reinvested at the internal rate of return that we have calculated. So all these cash flows are being reinvested at this rate. Now we are saying that's not true because these can be invested at any rate. What we know, the guide is your cost of capital or your work. What we know is that these cash flows can be invested at anything, but our guide is our work, the 9%. We can never invest this at a figure below 9%. So in modified internal rate of return, we try to correct that. In modified internal rate of return, you are saying these cash flows are being reinvested at the company's cost of capital or work. And in our case, they're being reinvested at 9%. So modified internal rate of return assumes that the project cash flows are being reinvested at the company's cost of capital. And we are saying that is much more realistic. So the project cash flows that we are generating every year, at the end of every year, are reinvested at the companies work. Project cash flows are reinvested at the work. That's the assumption that we make. So how do you do that now? Well, we use a formula, the formula which is given in your examinations. We use a formula, not a formula which is complicated, no. Okay, yeah, so we take out all these things now. So here's your formula here, people. Here's the formula. So that's the formula that we are going to use. Okay, let's paste the formula. Let's paste the formula so that we can use it. So the formula is here. Present value of the return phase over present value of the investment phase multiplied by 1 over n. Plus 1 plus RE. What is RE? That's our cost of capital, minus 1. So here there are a few things, investment phase and return phase. Okay? So let us finish off our question. Let's finish off our question. So it's here. The cash flows are here. So let's calculate a modified internal rate of return. Modified internal rate of return. Let's go. So the modified internal rate of return is the present value of the return phase over the present value of the investment phase. We go that way. 1 over n, then multiply by 1 plus the RE. Then you must remember to take out the 1 from all this. Okay, so let's go now. This is your investment phase. So that's the present value of the investment phase. When you add up this is the return phase. So this is the present value of the investment phase. This is the present value of the return phase. Okay, and your RE is your 9%. So please, can somebody add for me the return phase? Can somebody add for me the return phase? So this one is your 15,625. Return phase, please. What's the total?
16,947.
16,947. Good.
Correct.
47, like this.
Yes.
Yeah. Okay. What of the n? N is the time frame for a project, which is 3. So then you go, people, you go 16,947 over 15,625. 625 to the power 1/3. Then you multiply by 1 plus 9%. Then you're going to subtract 1 and you multiply that by your 100. Please, can you give me the answer? Can you give me the answer? Can we give the answer, please? Anyone with the answer?
$11.99.
Well done. Excellent. Oh, people are so accurate in this course. So these are modified internal rate of return. That's our modified internal rate of return. And we're saying this one is much more realistic. It's better. This one is better because the reinvestment assumption followed is more realistic. Now again, we don't expect big questions on modified internal rate of return. No, these are small items. The only aspect is that it's not covered in basic financial management. But in terms of us making a lot of noise over it, no, we can't make noise over this. No, we can't make noise over modified internal rate of return. No, it's not an item which is complicated. So those were our 3 items for this afternoon. I wanted to make sure that we are happy with the estimation of forward rates. Wanted you also to see how the concept of duration applies to investment appraisal and also the concept of modified internal rate of return. Now, there was a summary. We need to comment. This question wanted you to give us some comments between these 2 projects. What is your comment? Which project are we supposed to go for? Let's go. So here are the 2 projects now. So which project are we supposed to go for? Let's evaluate the results. Let's look at the results. NPV, this one is high. That one is low. Internal rate of return, this one is low. That one is high. Duration, well, this is the payback. Oh, sorry, first of all, payback. The payback. This one takes longer to pay back. Discounted payback, this one takes longer. Okay. Even this one also, it takes longer. So what we notice is that this takes longer. So we shoot it down. So which project are you going to go for between these 2? Which one do we go for? Payback is a measure of risk. That's another aspect that you need to remember. Payback is a measure of risk in investments. We go for projects which have got a shorter payback because they have got a low risk. So duration can be used also then to measure the risk of the project. Just like the traditional payback. So this project has got a high risk, but also it has a high return. Yeah, if you notice there. When you look at this project, it's got a low risk and a low return. So then, which project are you going to go for when you look at the absolute measures? When there's a conflict between NPV and IRR, normally we say NPV prevails. So a more realistic result comes from NPV. Now look at these two projects. This project can see that it's got a high NPV, but a high risk. Low NPV, low risk. So which one should we go for as a company? Which one do we go for? It all depends on what? It all depends on what?
Risk appetite.
Yes.
Risk appetite.
So if we've got a high risk appetite, you want a high risk, high return, you go for this one. Low risk appetite, you go for that. In other words, these two investments are risk efficient. In terms of risk, the return is commensurate with the level of risk. So they are risk efficient investments. We have no problem with them. The only guide is what is your risk appetite or risk attitude. Okay, people, that was our discussion for this afternoon. Where to? I now want you to go back to that question, the June 2015 question, and prepare it for the next class. So in our next class, we want to go for this big question. Somebody has already commented that this question is long. I agree with you. It's long. So you have now time, all of you, to read through this question number 1. Okay. So please read through question number 1. When you go through the question, pay more attention to the cash flows. The cash inflows. What are the cash inflows? Any investment appraisal question basically has got it. Cash inflows, cash outflows. It's got discount rates. It's got a time frame. So please look out for those items. That's what we'll be looking at in our next class. And then you pick another question on overseas investment. Then we move on to mergers and acquisitions. We move on to mergers and acquisitions. Okay.
Mr. Perry, have you sent this question? I just saw the video.
But I didn't send the question.
No.
Oh, very sorry. I'll share it just now.
Thanks.
I'll share it just now. Please prepare. You know, this question, if you haven't read through it in class, you will not benefit as much. Yeah, so please spend a bit of time, identify all the cash flows. That's a major item in this question. We have spoken about the exchange rate. Then there was a question about bilateral tax treaty. The bilateral tax treaty is going to arise in this question. We're going to see how you incorporate the bilateral tax treaty. Okay. Are there any people expecting results? Are results coming out tonight? Is it tonight when your results are coming out? What say?
Yes.
Tonight,
Tonight.
Please, those who are waiting for results, wish them well. Maybe that is why some people are not able to make it. Please, after results are out, you can contact us, we discuss, we chat the way forward together. Don't just drop off the course or just abandon the program. No, it's better outside this to give us a call. We have a chat so we can support you. All the best, all of you. So we'll see you Tuesday or your time.
Thank you.
Thank you.
Thanks.